so here's the introduction to 3.3. Two examples should do it. There's some new stuff for sure, but right here, this one will be basically two problems where you've already done it. And it was 2.7, and it was a hard, one of the sections that was probably the hardest of the chapter 1 and 2 that we did. So here's a nice little review, especially for those of you that have are going to retake the exam, because something like this will be on here. So I'll do the red one first, I guess, because it's on top. Okay, so I got a graph. Basically, you graph both at the same time on the same graph. So I'll do red. And so the way to go here is to find the intercepts. You can always solve for y and use slope-intercept form. But I think it's a lot easier to just cover up one of the variables and make it an equation that's real quick and easy to solve. Okay, and that finds the x-intercept. So in this case, that's right here. X-intercept is right there. Okay, and then we do the opposite. We cover up the opposite thing and find the y-intercept. Okay, because the premise is that one of the variables is 0 for the intercepts. So you just see what happens when it's 0. So when y is 0, 2x is 12, so boom, x is 6. And notice, what is y here at this point? It's 0. So we're just figuring out that when y is 0, x happens to be 6. When x is 0, well, what's y? Well, apparently it's 4. I swear that's a y. So y is positive 4. And then I cheated. I made the line beforehand. Okay, although it's not quite in the right direction here. And it is a solid line. So one of the ideas in 2.7 that was specific to 2.7, chapter 2, section 7, was that when you have an inequality and you're graphing a two-dimensional inequality, so with x's and y's, two variables means 2 dimensions, you got to make a solid line when it's a greater than or equal to, or when it's a less than or equal to. Okay? And then, so then what you do is you figure out, well, which way am I going to shade? And so you take this, and you pick any point on the plane that is not on the line. It's almost always easiest to pick 0, 0. So you put x is 0, so this is 0. Y is 0, so this is 0. And is this true? Is 0 greater than or equal to 10 or 12? Excuse me. Well, no. So this is where 0, 0 is. You're plugging in the coordinates of the origin. You're saying, hey, do numbers on this side of the line work? And the answer is no, they do not. So you would shade this way, up and to the right. All right, and so in 2.7, you would just shade everything up here and you'd be done with it all in the upper right-hand corner. You'd shade that, but we're not done. So the new idea here is that what you do, and actually this is the big thing you need to pay attention to. The big thing you need to pay attention to is that you only really shade what would be shaded for both inequalities, or heck, all three inequalities in theory. Okay? So here we want to graph with blue. Actually, there's no work to show. That's the nice thing about slope-intercept form, is that you know there's no work to show. You just got to know what to look at and how to interpret it. So the minus 3 means, boom, minus 3. You plot it down 3. Up 3 over 1, up 3 over 1, up 3 over 1, and so on. And since it's just less than, it's a dashed line. So I tried to make the slope right. Let's see how good I was. It's actually not bad. So there's our other one from the blue line, okay, from the blue inequality. So then we say, all right, which way do we shade? Well, if y is less than everything else, it's actually real quick to figure out which way to shade. You shade below. So I could indicate that really quickly. Shade below the diagonal line. Okay, so what is going to get shaded overall? Well, it's what is going to be shaded according to the red inequality and the blue inequality at the same time. So not over here, because heck, this isn't shaded for either of them. Not up here, because it's only shaded for one red. Not down here, because it's only shaded for blue. Whoops. Up here in the upper right-hand corner, because it's shaded for both. And let me bust out a highlighter. That'll be better. Blue's good. So here, it's up here in this corner, and especially with the tablet. Oh my goodness, that's good enough. You guys should be able to do better with pen and pencil and paper than I can with this stuff. All right. All right. By the way, make sure you are taking notes. I might check them. I might check to see if you have written some of the stuff down. If not, you might lose some points on your do now. Please take notes. Please do something that indicates you've been able to watch it. Write some stuff down. All right, so the next one. So this one is weird. This is going to be pretty new, but it's all right. It'll be all right. They're all kind of the same. So absolute value inequalities are ones that I think maybe students didn't like all that much. They are ones that traditionally students have problems with, but it's all right. And once again, this is actually a pretty good little review for if you are choosing to retake the test, because this is similar to, actually I forget what section offhand, one of them in chapter 1. So if you have absolute value is less than something, you automatically drop the absolute values, so x is less than 5, but that's not all you do. Don't stop listening right now. That's what a lot of people, they just say x is less than 5, which is true, but then also x has got to be bigger than negative 5. All right, and then the thing is with these videos, I'm not going to show why because we don't have enough time. I want this to be relatively quick and kind of an introduction to what you need to be able to do. We can talk about why that works the way it does in class. So this literally looks like x is between 5 and negative 5. Well, that's true. That's exactly where you would shade. You would have all the x's are between 5 and negative 5. So remember, if you think of, what you're doing is x equals 5 is the boundary, and x equals negative 5 is the other boundary. If you only look at this part, then you get x equals 5 as where that ends. X is greater than 5 until, or excuse me, x is greater than negative 5 until right here at this spot. And so what you do is, these are two vertical lines, if you might remember. I hope you remember from Algebra 1. X equals negative 5, vertical line. X equals 5, vertical line. So I'll come down here and grab them. So x equals negative 5 is right there. And it's a dashed line because it's just less than. Okay? So x is between 5 and negative 5. We indicate that by I'll do little arrows. You don't for real shade between until you look at all the inequalities. Okay, so you just got to have, you don't need to draw these arrows. You just have, at the very least, need to mentally know, okay, anything that's going to be shaded is going to be between these two lines. And then, oh my gosh, that's the worst arrow ever. But yeah, it would be this right here. This is what you would shade. Okay, undo, because I don't want to shade that yet. Then we go to blue line. Now the blue line, how does that work? Similar. Well, first off, I want to switch to blue, which apparently I can't. Similar, but you write y plus 1 is greater than 4, or y plus 1 is less than negative 4. That's how you handle these. Now this is kind of a review from the chapter 1 stuff where this comes up. This is how you handle absolute value inequalities. Okay, these are kind of the two types that you can run into. Okay, either absolute value is less than or absolute value is greater than. And that's how you handle these respectively. If it's greater than, in blue, you make two separate inequalities like this. Okay? These two separate things are equivalent to this one thing. You solve both of these individually, and they're both kind of relatively simple. Because it's one step at least. Y, subtract 1 from both sides, 4 minus 1, so you get y is greater than 3, or y is less than negative 4, y is less than negative 5. Okay? So those are two horizontal lines. The boundaries are, at least, So the boundaries are y equals 3 is a boundary. Okay? Y equals 3. I switched up the pen, so I'm not going to write y equals 3, y equals -5. Those are the two boundaries. So you grab the horizontal lines. Y equals -5 is down here. Y equals 3 is up here. So when you're graphing inequalities, remember the corresponding equations tell you where the boundaries are. Okay, when you're graphing inequalities, you're always figuring out regions in the xy plane to shade, and the lines tell you the boundaries of those regions. And then so where are you going to shade on both of these? Well, you're going to shade the areas that are either above this, okay, this where y is greater than 3, that's above this horizontal line, so boom, 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 or below this line. This is where y is less than -5, okay? And so where are we going to shade? Well, it's actually a little weird. This may all seem weird to you, but it's different than the first example. It's different than most of the problems, I would say. Highlighter, there we go, that's what I look for. It's between the red lines and above this blue line. So it's this region. This is what's both above 3 and between 5 and -5. It's above y equals 3 and between 5 equals negative plus or minus 5. And then similar down here. Okay? So carefully watch this video. Try to figure out what I did. These are pretty challenging. Make sure you can understand the first example. That's a standard one. This is kind of a more advanced one that I probably maybe should have waited to do together in class when you can stop and ask questions. But either way, we'll have time tomorrow in class to take care of it. But there you go. There is the video. Hopefully that tells you everything you need to know. Be successful on the classwork tomorrow.